Now that we know how to measure properly and get the correct amount of digits, it's important now that we know which of our digits are actually considered significant figures. So I've got 3 rules and kind of a 4th additional rule to help you guys know which of these digits in our numbers are considered significant. So the first rule is any number that is not a 0 is always significant. So we'll go through some of these examples here. So if I have some numbers, let's do an example. If you have 5, you can count how many digits there are that are not 0, and that would be 1. So you have 1 significant figure. Like on the mechanical scale, we did the measurement and it was 5.51, I believe, grams. And so if we wanted to count our significant figures here, not a 0, that's not a 0, and that is not a 0. So that adds up to 3 significant figures. And let's say you had an even more precise scale that could tell you it's 5.5137 grams. That one would be a sig fig. There's a sig fig. There, and there. So that would be 5 significant figures. All right, so that is rule number 1. Rule number 2, I like to call this one the sandwich rule. Any 0 that is between significant figures is also considered significant. So if we want to go over some examples for this one, when we measured our graduated cylinder, I believe we said it was about 40.2. And using our first rule, we know that 4 is not a 0, so it's significant, and 2 is not a 0, so it's significant. And now with this rule, any 0 between significant figures is also considered significant. So that will be 3 significant figures. Let's say I had a number like 40,005. Using rule 1, we got 2 significant figures, but then using this rule, we know that we have to include all these zeros in between to also be significant figures. So that would be 1, 2, 3, 4, 5 sig figs. Similarly to this, let's try another rule. What if we had 40,500? So we know 4 and 5 significant figures from rule number 1. Now we're going to use the sandwich rule. This 0 is between our significant figures, whereas these zeros over here are not. So this 40,500 would only be 3 significant figures. All right, and now moving to our third rule. It's where it gets a little more detail here. Any 0 that is both on the right side of a decimal and on the right side of another significant figure is considered significant. All right, so if I were to give an example for this one, I will do 6.20. Those two are definitely significant figures from rule number 1. And then the question would be this 0. So it doesn't follow the sandwich rule, but it is both on the right side of a significant figure and on the right side of a decimal. And because it is both of those, that 0 would be considered a significant figure. So this is 3 sig figs. Let's do a few more examples because this rule is a little bit harder to pick up on. What if I had 620? If I had 620, I would know the 6 and the 2 are still significant figures. This 0 is to the right of the 2, but it is to the left of the decimal. So that one would not be a significant figure. So this one's only 2 sig figs. And let's say, we'll do a few more of these. Let's say I had, oops, let's do this all in the same color. Let's say I had 60,000 and 20. Those would both be significant figures. And these would, because they're sandwiched in between 2. This 0 is on the right of a significant figure, but again on the left of the decimal. So that would be only 4 sig figs. And I apologize, I just did that one all off camera, so I'll move it up. And we'll do a few more. Let's build off these same numbers. So let's try something like 60,000 and 20.05. So this one's a little more complicated, but again, we could just focus on the sandwich rule. If there are zeros in between 2 significant figures, they're all going to be significant. So 1, 2, 3, 4, 5, 6, 7 sig figs there. And then let's take this one more time. All right, so what if we had this number here? 6 is significant, 2 is significant, 5 is significant. And we said last time these are all significant because they're in between our significant figures. And then we have these 2 zeros over here that we don't know of, but they're both to the right of a significant figure, and they are both to the right of the decimal. So they are both considered significant figures. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then if you follow those 3 rules, you should be safe every single time, but I like to put this one just in case people get confused. Placeholder zeros are not significant. So let's go over some examples of what a placeholder zero is. So if I wanted to write something like 70,000, I would be finding my significant figures. That 7 is a significant figure, and none of these other zeros are, because they are to the right of my 7, my significant figure, but they are also on the left side of my decimal. These are what we call placeholder zeros. Placeholder zeros. Because they're kind of just holding that place. So this would only be 1 sig fig. So that is one type of example of placeholder zeros. I want to give you another example of placeholder zeros. I'm just ripping all my paper up, I guess. So if I had a really small number like 0.00025330, and I wanted to know how many significant figures that was, I'd have these three. None from the sandwich rule. And then this 0 right here is significant because it's on the right side of both. So that's a significant figure. But these on this side would be non-significant. So we would call these ones, these are also placeholder zeros. They're kind of just holding the place so that you could write these numbers out here. So looking at this, we'd have 1, 2, 3, 4 significant figures.